Now we're talking about sine or cosine functions that have a change to the period of the function. In other words, they change how long it takes the function to repeat itself. You can see this sine function that I just highlighted goes through one full cycle of its wave in a distance of 4 pi. So in this case, 4 pi would be the period. And what we want is to figure out which one of these graphs match the equations over here. Take a look at the equations. There's no change in A. Okay, they're all amplitude of 1. There's no change in K, the midline. They're all midline equals 0, or y equals 0 for the midline. There's no phase shift, right? We're not dealing with phase shifts yet. We're just focusing on B. Okay, we're talking about that horizontal scaling factor B and how that plays into the period of each function. So let's keep talking about this 4 pi function. I want to talk about that. Remember what period is. This is the equation for period. It's 2 pi divided by b. And what we've just said is that the period for this function is 4 pi. So can we solve this equation and figure out what b is? We just multiply both sides by b. This becomes 2 pi equals 4 pi b. And now divide each side by 4 pi. Okay, and that'll give us our answer for b. Okay, 4 pi over here. And these 4 pi's cancel out. We just get b equals 2 pi over 4 pi. The pi's also cancel out. So what is this really? This is 1/2. Okay, so where is b equal to 1/2? Which one of these guys matches? Remember the equation. Okay, it's going to be b times x. So which one is 1/2 times x? That's this one right here. Okay, sine of x over 2. And one last check. Is this a sine function? Well, I think that looks good too because it starts at the middle, goes up, hits the middle again, go down, and then back to the middle. So we have our 5 key points there. They fit within a period of 4 pi, and that matches the b of 1/2. Now let's see. You can see in this, sometimes you can just look at it and kind of get an idea of what's going on. Like this one over here, super stretched out. So we would expect that for this one, I would expect that b is less than 1, right? Because when b is a fraction, a small fraction, then the curve gets stretched way out. But for some of these, you can see the curve is like vibrating very, very fast. The period is small in this one, so I would expect b to be greater than 1. It's been compressed horizontally. So let's talk about that one in the upper right. I like that one. I need some space to write here. Go away, all of you guys. Okay, so let's talk about that one in the upper right. And take a look closely what's happening here. Okay, how long does it take to complete one cycle of that cosine curve? Well, according to the graph, right here is pi. Okay, so the period, I would say, equals pi. And if you remember, that's 2 pi over b according to our formula. We multiply each side by b. I get b pi equals 2 pi, and then I divide each side by pi, which is going to give me b equals 2. So where is that in our list here? Fraction, that's not it, fraction, here we are. Cosine of 2x. So, does it match a cosine function? Yeah, that works too, because you see it starts high, and then goes down to the bottom, comes back up, and ends at the last key feature there, back up where it started. Okay, so this is our cosine function of 2 pi. In general, just remember that as b gets small, right, b less than 1, it's a fraction, those are where you're going to have stretched out functions. And when you have b greater than 1, that's when you have compressed functions.